Then the queen gives up this job. In small societies, primitive societies, the queen does all this work. In large societies, the queen cannot afford to do this work. She uses a chemical to suppress reproduction, and then she leaves it to the workers to organize themselves. But how this transition happens from top-down control to bottom-up control has never been studied. We studied theoretically in some way. People have built models and said if the society becomes large, then there is greater advantage in bottom-up control, etc. Never been studied empirically. And I believe that these two species allow us the opportunity to experimentally investigate this transition. They belong to the same genus, they are very related, they live side by side. You can find colonies in the same place. And by doing more experiments on this, I hope that we will actually study this experimental transition from top-down to bottom-up control, which I find very interesting. Sorry.
Okay, well, thanks for this nice talk, and yeah, we'll start a little discussion. And I want to ask you, what do you think of the idea that these first labs you explained, who might be also solo active, so they can manage on their own, and they, okay, but so they cannot make up like a really sophisticated and nice way of communication because they are not living like normal vast colonies for like all their evolutionary life, so they don't have this like bees, ants, and all that stuff. So they use violence to communicate in a very simple way. It's like nearly digital, bite me or don't bite me means, is it maybe that why that they don't have such a special decent way of communication because they are used to it, because they have to have like two programs running on themselves, like one solo program and one community program.
Our impression, only some of this is actually backed by good evidence. But the general impression is that the ancestors of all social instincts were solitary. This we can tell from biology.
There's everything solo.
Solitary, yes. The ancestors were always solitary. And there has been an evolutionary transition, in fact several times, from solitary lifestyle to social life. So if we imagine how this might happen, it might happen by small groups of individuals nesting together. Either by the daughters not leaving the mother's nest, or by a group of sisters coming together. Small groups live together. And there are some advantages. You can fight predators more easily, you can find food more easily, you can help each other. In these small societies, and if it is a new kind of behavior, you do not expect a sophisticated dance language, a sophisticated chemical pheromone. You don't expect any of these. Whatever behaviors, whatever what they had as solitary, they would use. And they would bite each other. If I was solitary was and somebody else tries to enter my nest, I will bite her. So whatever the machinery that a solitary species had is put to use, and it's a small colony. So if one individual becomes a queen, she can use physical aggression and suppress everybody else. So we think that that is stage one. And in fact, Sciatiform, the second stage, is actually at that stage one. And of course, you do not expect that they have already forgotten how to be solitary. So sometimes they can be solitary, sometimes they can be in groups. But when they are in groups, their entire machinery for organizing their social life is borrowed from solitary life. There, things can become advanced. And when you reach the honeybee life stage, you already have huge colonies. Nobody can live solitarily. They forgot how to live solitarily. And of course, they have evolved many new mechanisms such as dance language, pheromones, and various other communication systems, and bottom-up control. That's the final stage. And we believe that cooperative marginal lies in between. It is still not forgotten to be solitary. It still has small colonies. But it has started evolving this new machinery for social life, such as bottom-up control, such as pheromone produced by the queen. And our major conclusion, therefore, is that many new things happen when you go from solitary to the advanced society. Question is, what is the sequence in which these steps are required? And now we are in a position to say that pheromone and bottom-up control comes first, The colony is becoming huge. They are being morphological different from queens and workers. Forgetting to live solitary, these come later. So these species allow us to trace the sequence of steps. Which ones you acquire first, which ones you acquire later. So we think that market data is in between. Cytophonia is really primitive and honeybees are at the end.
Is there already a trend visible which is the most, okay, if you say evolutionary clever way of living? Is it more the big bee state, or is it the being more in a solid way of living, or is it this what you research?
That's very hard to say. That really depends on our point of view. My own belief is that intelligence in animals is decided by the ecology of animals. Ecology. I am as intelligent as my ecology requires me to be. If I live in an environment where there is no challenge, no predators, nobody is cheating, there's plenty of food, I will be a fairly dumb individual because I don't need to invest in that. If I live in an environment where there's a lot of predation, no food, everybody is trying to cheat me everywhere, then I turn out this thing. The brain size, the number of neurons, your position in evolution is a minor determinant of levels of intelligence. Your ecology, in my opinion, is the greater determinant of levels of intelligence. A little honeybee can be as intelligent or sometimes more intelligent than a chimpanzee because she needs it for her survival. Many people have argued that, as the brain becomes bigger, you have more neurons, you become more and more intelligent. I don't buy that argument at all. I think brain size and number of neurons may explain 10% of the variance in intelligence in the animal kingdom. I think 90% will be explained by ecology. So, each species is as intelligent as it is required for it to be survival. Evolution will never make you intelligent if we look at survivors that are going to do it. Why should you be intelligent? Why waste resources on intelligence? You can actually put it all into production. So I don't think we can say which is smarter. The smartness is dictated by the ecology. And even in a short lifestyle, you can see that this is what we do. If you go to some place where people are likely to pick your pocket and people are likely to steal your luggage, you will become very clever, very smart, very awake all the time. If you come to a place where there is no violence, no cheating, nothing, you relax. So I think in an evolutionary landscape, it's exactly what it is. So I would not classify some of us as smarter than the others.
Okay. Questions from here?
Would it be predictable by the feeding process which larvae is going to be potential queen?
We're trying that. We already have evidence. In the case of honeybees, what makes the individual queen is in fact the food. But there is a qualitative difference in the food. One kind of food makes a worker, another kind of food makes a queen. But our species, as far as we can tell, have not reached that stage. But we think it is the quantity of food. Less food, you don't become a queen. More food, you become a queen. But you must remember that become a queen, don't become a queen is not a binary decision. It's a continuum. I have 90% probability of becoming queen, or I have 20% probability of it. It's not a binary decision. And we think that this is dictated by the quantity of food that you receive as a person. Once again, we have correlation evidence, not yet experimental evidence. And we are trying to do experiment, but it's not easy to do this experiment. It's very interesting. If I take a nest and I randomly mark, I say, I'm going to choose this for more excess feeding and not the others. And I start doing the experiment. What do the adult wasps do? They say, this guy has been fed by the researcher, so let me feed this wasp. So they will undo what you are doing and they will equalize everything. So it's not easy to do. It's very hard to do these experiments. And you can't isolate them and grow them outside. So we're trying, but it's not easy to do the experiment. The wasp will always undo what you are trying to do. So we have differential treatment at the same nest is very hard. So what we're doing now is something not so satisfactory. We take one nest and we give it lots of food. We take another nest and we don't give it any food. And then we see whether the wasps which are born from this nest have more chance of becoming queen. So we can't do it in the same nest, we have to do it in different